Assalamu alaikum. My name is Hanan Ahmad and my registration number is 21TE25. Today we are going to discuss digital signal processing lab number 9, in which we learn about FIR filter using window methods. So the task 1 is from example of the book 7.4, plot the filter in time domain along with its magnitude response. So let's see example 7.4. As we can see, it has seven filter coefficients named as H0, H-1, H1, H-2 and H2, and also H-3 and H3. So let's move towards the source code for this task. So we can see, first of all, we have filter coefficients. We use them in the array, and the plot filter in the time domain where n is equal to range, that is basically range from -3 to 3. To plot this graph, we use temp command and then label the graph where x label is labeled as sample while the y label represents amplitude, and the whole graph title is filter impulse response. After this, calculate the plot magnitude response. For this, we have n is equal to 1024, that is the number of frequency points for plotting. Then we use FFT command, and then we have frequency. Then we use magnitude command, that is absolute of h, to find the magnitude plot. To plot this graph, we use figure command. Then use plot command to plot this graph. Then label this graph where x axis represents frequency and the y label represents magnitude, and the title is magnitude response of the filter. So let's simulate this code. Basically in this task we obtained two graphs. So first one is filter impulse response. As we can see, on y-axis there is amplitude and on x-axis it is sample. So the second part is magnitude response of the filter. On y-axis we have magnitude and on the x-axis we have frequency, that is in radians. So let's move towards part B. In part B we use windowing, that is Hamming, Hanning and Blackman, with filters, and observe their magnitude response and discuss the window's magnitude response, and n is equal to 512. As we have filters coefficients, and then where n is equal to 512, then we apply the Hanning Blackman window functions, and then we use calculate and plot magnitude response. For this we have to plot magnitude response of the separate windowing. First of all, we plot Hamming window graph, and then Hanning, and then Blackman. So then we use plot command to plot the graph of Hamming, and then plot command used for Hanning and then Blackman, and label this graph. So let's simulate this code, and so we can see that we obtained only one graph. In that we have three graphs. Basically first one is Hamming window, and the second one is for Hanning window, and the third one is for Blackman window. So let's move towards task number. In task 2, we have to plot the signal in time and frequency domain along with its magnitude response, where we have given these parameters. First one is sampling frequency, that is 8000 Hz, and then time, and we also have three signals named as x1, x2 and x3, where x is the sum of all the signals, that is the whole signal. So let's move towards source code. First of all, we define the parameter that is given. Then we have to plot the signal in time domain. For this we use subplot command, then plot, and then label x label as time and y labeled as amplitude, and then title as signal in time domain. Then we have to calculate and plot magnitude response. For this we have n is equal to length of x and then use FFT and frequency we have normalize the frequency and then we use subplot command and then plot, then labeled as x-axis as frequency and y-axis as magnitude and labeled the graph as magnitude response of the signal and set the frequency limit that is range from -2000 to 2000. So simulate this code. As we can see we use two graphs. First one is signal in time domain and the second one is magnitude response of the signal. Now let's move towards task number 3, that is applications of FIR filters. In first part we have to examine the noise reduction for considering the example number 7.4. So let's move towards the source code for this task. First of all we define the filter coefficients, that is H, and then generate a noisy input signal. For the sampling frequency is 8000. Then given the time and the given that is signals, three signals that is given, we use that, and then we apply Gaussian noise and then noisy signals and then apply FIR filters to perform noise reduction. For this we use convolution of the noisy signal with the original signal. Then use plot the original signal, noisy signal and filtered signal one by one. So for this we use subplot command. Then first paragraph we use label x-axis as time, y-axis as amplitude and title the graph as original signal. In the second plot we have to plot noisy signal. For this we labeled x-axis as time, y-axis as amplitude and the title as noisy signal. Then use subplot command same as above to plot the graph of filtered signal and entitle these graphs. So for play the signals of original, noisy and filtered we use sound command and then pause the previous command. So let's simulate this code and see. As we can see, first one is original signal and the second one is noisy signal and the third one is filtered signal. In the part B, we have to find a given space signal, discard required frequencies as given in example and observe the results. So we have given audio signal. So let's go towards the source code. First of all, we have given the path for that music track and then define N and then FFT. To discard the required frequencies, we use these commands and then reconstructs the remaining signal, that is basically our filter signal. For filtered speech, we use inverse Fourier transform and then play the original signal and filtered speech signals, and at last we use pause command to pause between signals. So let's simulate this code and see. So let's move towards part C. In this task we have given a music file. We have to apply high and low pass filters to observe the results such as tweeter and woofer. So let's move towards source code. So first of all we given the path of our audio signal, then we have to find high pass filter. For this FC high is equal to 500 Hz, and then we have to find for low pass filter as low frequency is 10,000 Hz. and then use filtered high and then use filtered low command to filter the given signal, and then use sound command to play the signal, and then use pause command to pause, and then resume the signals. So let's simulate this code and see what happened.